Okay, this is exam 2 for Physics 102, Spring 2011. Which of the following equations for this circuit is correct? So just go through the circuit and each item and see if it's correct. The first one is minus 6 minus 8I1. Now if it was minus 6, that means I would be going in this direction. But then the next element is this 8I1, so I'm really going in this direction. So this should actually be plus 6. So A is not right. Then I have 6 minus 8I1. That's correct. Positive 6 minus 8I1 plus 2I2. I'm going against the current, so that's correct. Minus 12. That's correct. And then minus 4I1. So that's correct as well. I'm going with the current. So the answer looks like it's B. Let's just go and look at these other two. I have 12 minus 2I2. It's going in this direction. 12 minus 2I2. That's correct so far. Minus 8I1. I'm going against the current, so that should be plus 8I1. And then I have I1 plus I3 is equal to I2. My incoming currents are I1 and I2, so that should say I1 plus I2 equals I3. So the answer to 1 is B. Consider the above circuit. If I2 is 2.45 amps, what is the magnitude in the direction of I3? All right, I know that I2, 2.45, and I want to find I3. So I'm going to have to create an equation for this right loop. Starting here, going in this direction, I get 12 minus 2 I2 minus 3 I3 is equal to 0. I know what I2 is. That's 12 minus 2 times 2.45 minus 3I3 equals 0. 12 minus 2 times 2.45 is 7.1. So I3 is 7.1 over 3. Which I get 2.4 amps. Actually 2.37 amps, and it comes out positive, and I3 then is shown as down, so that's correct. 2.37 down. D is the answer for number 2. The following circuit is relevant for the next 4 questions. What is the equivalent resistance? Alright, well first we want to start with this. It's in parallel, so it's 1 over 1/2 plus 1/2. That's equal to 1, so I can replace this with a 1 ohm resistor, and then I replace both parts of this parallel branch with 1 plus 1 is 2, and then I resolve that into a single resistor, and it's just like we did before. It's just 1 ohm. Alright, so the answer is A for number 3. For the circuit, what is the potential across R3? Alright, I want to know the potential across this resistor. I know that it shares that this 1 ohm resistor and these 2 resistors combined share 12 volts, and that those two, the equivalent of the 2 parallel, that is the equivalent of the 2 ohm resistors, is the same. It's 1 ohm as R5. So I get 6 volts across this branch and 6 volts across this resistor. So since I have 6 volts across that parallel branch, then I also have 6 volts across R3 because they're in parallel. So the answer for number 4 is C. For the circuit above, if R3 is removed, what happens to the current through R1? Alright, if I remove a resistor from this branch, it does not affect this branch at all. Alright, it's like your house circuit. Taking a device out of your house doesn't affect your other devices, so it remains the same. B is number 5. Number 6, consider the above circuit. Which resistor has the least current traveling through it? Is it R1, 3, or 5? The answer is R3. I have the same current going into both of these branches right here. The same current going into both of those. And that current is split evenly in these 2 branches. So let's say that this is, I don't know, 2 amps or whatever. Well, it's actually Well, it's 12 amps. So you get 6 amps here and 6 amps here going into these two parallel branches. And so that gives you 3 amps through each of these resistors. And 6 amps here, and then you get 6 amps, 6 amps. Alright, two pieces of copper wire the same length. The diameter of A is twice that of wire B. How do their resistances compare? This is just like the concept test, number 7. It's C. I like to think, was RA bigger or smaller than RB? The resistance. RA has a bigger diameter, so its resistance is less. The diameter is off by a factor of 2, and we square the diameter to get the area, and so its RA is equal to a quarter RB. Which light bulb in your house draws more current? P is equal to I squared R. And so the higher power has the higher current. That's B. In a circuit breaker, you have a 1200 watt heater. You have all these devices. When you add a television, the circuit breaker turns off. They all operate at 120 volts, which is the maximum allowed current for the breaker. Alright, this draws 10 amps. I just want to figure out the current. I is equal to P over V, the current drawn by each. So 1200 over 120 is 10. 120 over 120 is 1 amp. 1 amp. And then you add a 4 amp device. So the circuit breaker is doing okay when you have 10 plus 1 plus 1. So that's 12 amps. But when you add 4 more amps, that's 16 amps total. Somewhere in between there it turns off. The circuit breaker turns off. So somewhere between 12 and 16 must be 15 amps from the available answers. So number 9 is E. Which of these statements about a household circuit is true? It's a parallel circuit. That's correct. All devices operate at the same current. That's not true. They operate at the same voltage. As you add more devices, the potential across each device decreases. That's not correct because they're all in parallel, so the potential stays the same. It's a good thing. Circuit breaker turns off if IN is greater than I out for any particular device. That's not true. The circuit breaker turns off if the total current exceeds a certain amount that protects the circuit in your house. This is for a GFCI. So the answer is just 1. That's option B. Number 10 is B. Which of these best describes why some materials are permanent magnets, so-called ferromagnetics? Right, these materials are found in the center of the Earth. Okay, that's true, but that's not the reason. These materials are made of metal. That's often true, but not the reason. These materials contain charges. Right, it's true that they contain charges, but so does everything else. And the magnetic domains are aligned. Right, that is true. Number 11 is B. Figure shows a loop of wire through which current flows. What direction does the loop turn? So I have a magnetic field running in this direction. That's B. I use my right-hand rule. I can just say take the right-hand side of this loop, fingers in the direction of I, fold towards B. That gives me a force that is downward. Likewise, I have a force that's upward on that side that makes clockwise. Through the loop of wire, what happens to the coil as time continues? Right, when the coil flips halfway over, those forces switch, and so it's going to oscillate back and forth. Option A. Positive charge is traveling toward a wire as shown. Initially, there's no current. What direction will the charge travel when the current is turned on? Alright, so if I turn the current on, that produces a magnetic field that's into the page and out of the page on this side. So this charge going into a magnetic field that's out of the page, let your fingers go in the direction of V. They fold towards B, and so the force, your thumb gives the force, which is down. So number 14 is A. Negative charge enters magnetic field as shown. In what direction will it feel a force? Alright, so V is up, B is out of the page. That gives you left, but it's a negative particle, so it should be right. So number 15 is E. Number 15 is E. There's a mistake on the key for that. Number 15 should say E. I'll try to make a note of it at the end. Oh, actually, no, I'm sorry. No, the key is correct. So V is up, B is out of the page, that is towards you, and that gives you right. So the force then is to the left. So the force is to the left, so that's C. So 15 is C. So the key is correct. Right, number 16, an electron moving freely in a circular path perpendicular to constant magnetic field takes 1 microsecond to complete 1 revolution. What is the magnitude of the magnetic field? Very similar to a homework problem. We know from the cyclotron equation that R is equal to mv over qb. Right, I want to know the magnitude of the magnetic field, so I just solve that for B. That is mv over qr. Alright, so that's mv is going to be the distance, 2 pi r, over the time, divided by q times r. R cancels out, which is a good thing because we don't know it. And now I can just put in values. An electron has a mass of 9.11 times 10 to the minus 31 kilograms. We have 2 pi. It has a charge of 1.6 times 10 to the minus 19 coulombs. And t is 1 times 10 to the minus 6 seconds. So I get 3.6 times 10 to the minus 5. That's in Tesla. Must be B. 16 is B. Point A is equidistant between these long parallel wires. What is the direction of the magnetic field? Alright, due to this wire, the magnetic field is coming out of the page, and then due to this wire, it's going into the page. So these two cancel out. Okay, so the answer to this is E. There is no magnetic field. Alright, you push a 1 meter long piece of copper wire through a magnetic field that has a magnitude of 2.4 Tesla, shown in this figure. You push a force of 12 newtons. What current is created in this wire? This is how a generator works, right? You push a wire through a magnetic field with a certain force, and we can figure out what is the current by this expression. The angle theta is 90 degrees, so this just goes to 1. I can just leave that off. I'm just going to solve this for I. It's F over LB. That's 12 newtons over L, which is 1 meter. And the magnetic field is 2.4 Tesla. 12 over 2.4 is 5 amps. So number 18 is D. What direction is the current? So our force, you have to use the right-hand rule, but you sort of have to go backwards. Our force is to the right. The magnetic field is into the page. Magnetic field, get my hand right here. Magnetic field is into the page. That means that my current has to be going well, hold on. I think the key is the current has to be going down in this case. Alright, the current has to be going down. So number 19 should be C. 19 should be C. Yeah, 19 should be C. These are the types of light in the electromagnetic spectrum listed alphabetically, arranged in order from the lowest to the highest. Okay, the lowest is radio, and micro, and ultraviolet, and then gamma rays are the highest energy. So D for number 20. Number 21, this figure shows the path that light travels through 3 different materials. Which of these best describes the relationship? Alright, so first, what is N1 to N2? Alright, well, light travels faster in N2. To move away from the normal, light travels faster than in N1. So that means that N2 is less than N1. And then moving from N2 to N3, light travels slower in N3. So that means N3 is greater than N2. And similarly, if I'm moving from N1 to N3, light travels slower in N3, so N3 is greater than N1. So let's see, N2 is less than N1. That gets rid of that one. And that one. N3 is greater than N2. That gets rid of that one. And let's just check N3 is greater than N1. Alright, so the answer should be A for number 21. In this figure, light travels from water to glass. What must theta 2 be for the total internal reflection to occur? I remember this is total internal reflection occurs when this angle is 90 degrees. But if I'm moving from a low index to a high index, my ray is actually going to bend towards the normal, so total internal reflection will not occur. Now, if you just want to calculate this to see, you can say that 1 sine theta 1 equals 1.5 sine of 90, which is 1. And then so theta 1 is the inverse sine of 1.5 over 1, which gives you an error when you try to do it in your calculator. Light travels through a 10-meter length of glass, which the index is 1.5. How long does the light take to travel this distance? All right, well, V is equal to C over N. That's 3 times 10 to the 8th meters per second. That's the speed in a vacuum divided by 1.5. That's 2 times 10 to the 8th meters per second. And I want to know how long does it take to travel that distance. T is D over V. Looking at my units, this would be meters over meters per second. The meters would cancel and leave me with seconds, which is the time. So that's 10 meters over 2 times 10 to the 8th, which is 5 times 10 to the minus 8 seconds. C is number 23. Light is incident and travels through 3 slabs of material are shown here. Theta 1 is 30 degrees. What is the angle theta 3? Alright, so I can say that N1 sine theta 1 is equal to N3 sine theta 3. I can just forget about the middle slab. It doesn't really affect this answer at all. And that's 1.2 sine of 30 equals 1.1 sine of theta 3. And this is 0.6 equals 1.1. So theta 3 is the inverse sine of 0.6 over 1.1. Which is 33 degrees. So the answer is B for number 24. Number 25 says, select the words that best complete this sentence. Huygens proposed a theory, described light as a wave. He said light was a wave based on the properties observed in refraction. So B is 25. This figure shows an incoming ray that is incident on a right angle mirror at an angle of 30 degrees. What is the angle theta 2? Right, so this angle is 30. That means this angle is 30. That means this angle has to be 60, and this angle has to be 30. Right, this is 60 because this is a perpendicular angle. And this angle here is 30 because it's a triangle. So if this is 60, this is 30. Now if that's 30, this is 60. And so this has to be 60 degrees as well. Notice that it's not drawn to scale as it says in the problem. So number 26 is C. Light travels from glass to air. The index of refraction is 1.5. What must be the incident angle for light in order for total internal reflection to occur? Now in this case, I'm actually going from glass to air, from a high to low index of refraction. So refraction does occur. So I just say N1 sine theta 1 equals N2 sine of 90. I'm traveling from 1.5, that's for glass, sine of theta 1 is equal to 1. So theta 1 is the inverse sine of 1 over 1.5. Which is 42 degrees. So it's E. Okay, let's see, number 19 here should be C.